All right, histograms look like bar graphs, but they aren't bar graphs. They look like a bar graph. However, instead, the bars or columns, columns is the word for vertical, right? Touch. When you make a bar graph, right, if you're collecting data and the data you're collecting is favorite popsicle flavor, right, you would say cherry, banana, lime, orange, purple. I'm not sure, it doesn't really taste like grapes, it tastes like purple, right? But you would have your data that you'd collect and you'd make your bars, but the bars would not touch. There would be a space between the bars. A histogram, here's a bar graph. Your bars do not touch in a bar graph. A histogram, it's smushed together and the bars touch each other. And they touch each other because the x values, your data, the x values are ranges. So you could not use qualitative data in this, right? You can't have a range of what's your favorite popsicle flavor and you say, oh, I like anything in the range of cherry to banana. That doesn't work, right? But if I said, what's your shoe size? You could fit that value into a range. If I said, all right, everybody who has a shoe size of 6 to 6.5 over here, and from 7 to 7.5 over here, and from 8, right? You could fit in those ranges. What you need to know about the ranges is that the ranges should be constant. You cannot say, I'm going to put this range as people with shoe sizes from 0 to 5, and the next one is 5.1 to 6, and the next one is 6.1 to 14. They have to be consistent ranges. So you have to be able to distribute, to divide your data up into consistent pieces. They're called bins. Your ranges are called your bin width. They're called bins. All right, let's write down this data. Your data is as follows. Are you ready? 10, 15, 20, 15, 16, 20, 18, 34, 9, 10, 17, 25, 26, bless you, 28, 30, and 31. So there's our data that we are going to analyze. So we're going to make a histogram, but before we make a histogram, we have to take our data and we have to divide it into ranges, right? We have to divide it into our bins. So this is sometimes the hardest part for students because you think that your bin widths are the same, but you haven't counted it out. So I'll help you out in the beginning. Our first frequency, our first bin width, we're going to make a tally chart, right, is 9 to 15. So any data that falls in between 9 to 15, I'm going to tally it out up here. I'm going to mark its frequency. So I have 1, 2, 3, 4, 5 pieces of data. Now let's count how many data values, or how many elements, how many spaces, what's the quantity from 9 to 15. So you can't just say, oh, I'll subtract, because you have to count the number 9 and you have to count the number 15. So 9, 10, 11, 12, 13, 14, 15. There are 7 values in here. So my next one is going to be 16. So 16, 17, 18, 19, 20, 21, 22. 16 to 22 is my next bin width, my next range. So 1, 2, 3, 4, 5 pieces of data. I'm going to start at 23 for the next one, right? 2, and then we go 23, 24, 25, 26, 27, 28, 29. So 1, 2, 3. And last bin width, 30 to 36, right? Because I'm doing 30, 31, 32, 33, 34, 35, 36. And that's 1, 2, 3. So if I was going to make my histogram, it's a bar graph. 1, 2, 3, 4, 5, 6, 7, 8, right? This is my frequency. And down here will be my bin width on my x-axis. And I can do a little squiggle, show it doesn't start at 0, right? Or I can just go 9 to 15, which would be 5. 16 to 22, which is also 5. I guess I should. I want my bins to kind of be the same width so that it's not misleading, that you think the wider it is, the more data it has. And then 23 to 29 would be 3. And 30 to 36 is also 3. This is a histogram. The pro, the positive slash con, negative of a histogram is that everybody's histograms could look different. Why is that? Why could your histogram look different from someone else's but still be correct? What? Yeah, your bin range. If I made my bin range 6, but Aiden made his 5, could that change the way my histogram looks? But it would still be correct. It would still represent the right data. So they can kind of be manipulated to make it look the way you want it to, within reason. The downside of a histogram, if you did not have the data, you just had the histogram, and I said, what's the maximum data piece? You don't know what the maximum number is. You don't know specific data. You know that the maximum lives within the range of 30 to 36, but you don't know specific data. If I say, hey, what's the number that occurs the most? What's the mode? Could you tell me? No, because we don't know specific data. So you can't talk about specifics with a histogram. You can talk about generalities with a histogram. You could say, oh, you know what? Most of the data falls below 22. You can make general statements, but you cannot specifically speak about individual pieces of data. All right, I want you to change your bin width. I'll give you the first bin width. 9 to 13. 9 to 13. Let's see what that is going to do to our histogram. How much different this is going to look by changing our bin width. So I want you to work with your peers, work at your table, create your frequency table, create your histogram, and talk about the difference, what happens, because all we're doing is shaving a few numbers off. How is that going to change it? That's your first bin width.